INT 21 interrupts. So INT 21 interrupts is a type of DOS interrupts. I will tell what it performs. So INT 21 interrupts are mainly used by programmers to give the string inputs to accept the keyboard 8-bit input value from the users, or if you want to terminate the program. For example, after completing instruction, you want to terminate and you want to view the output from the program. In order to terminate the program, we use some types of set of instruction and interrupts to do that operations. So now we will see how to use interrupts, how to get input from the users using some set of codes, and how to get some string input from users, how to display the input in the screen, how to display strings in the screen, and how to end the program, how to terminate the program by using interrupts. So now I will share my screen. I hope the screen is visible to everyone. Uh, INT 21H, it's a one type of DOS interrupt. It's mainly used by system programmers. For example, if you want to do programming in software, programmer use INT 21 interrupts to give the inputs to the programs. For example, if program asks input from users, if you apply some values, if you want to accept the values from user side, we use some set of interrupt commands or interrupt instructions to accept the value from users. Similarly, if you want to accept string input from users, we use another set of codes in INT 21 to accept strings. Similarly, if you want to display numbers on or in the program output window, we use some set of codes, instructions, or interrupt commands to display 8-bit numbers on the screen. Similarly, if you want to display strings output on the screen, we use another set of functions. Thus, by calling the interrupts 21H, we can be able to accept inputs, accept strings, display inputs, display strings, like that. All these functions can be easily possible by making use of this INT21 interrupt functions. Similarly, if you want to end the program and if you want to terminate the program, it is also possible by simply calling the INT21 by using some set of codes. I will explain what are the set of codes, how to use in programs, and how to accept inputs, and how to display the value strings in the output window. So as a name it serves INT21. INT stands for interrupts. This will interrupt the program and do some operations. So DOS provides various internal interrupts which are used by system programmers. System programmers use this set of INT21 in while doing program to ask the input from users. For example, input may be a data, output may be a strings. If you want to accept data from users means we use some set of codes. Similarly, for strings, we have separate instructions to get input string from users. I will tell what are all the commands we need to use during programming. The most common used interrupt is INT21. It invokes inbuilt DOS function which can be used to perform tasks such as reading a user input's character from the screen. For example, if you want input from the users, so user types some 8-bit data from keyboard. It's mainly used for getting the user inputs, characters from the screen. And for displaying the results on the screen, mainly used for getting the user inputs and also for uh, displaying the results on the screen. For this two function, we use INT25. So INT21 is a type of a DOS type interrupts. It's mainly used for two different functions. First, main function is to get input data or strings from user side. And second function is after getting the data from user side, you want to display the data and strings in the output screen. So to display data and strings in the output screen, we need INT 21. This interrupt, DOS interrupt, have a set of commands, set of instructions or set of codes to get data or string from users and also to display the data and strings in the output screen. We mainly system programs mainly prefer INT 21 as an interrupts in 8086 to do the data functions. To get data, to display data, strings in the output stream, we mainly prefer INT 26 system programmers to do the operations in 8086. And while calling the INT 21 DOS interrupt, we first assign the correct value in AH register. We first assign the correct value in AH register. We use AH register to accept the values. So I will tell values assigned to the AH. Based upon the value assigned to the AH register, INT 21 performs different functions. So based upon the value assigned to the AH register, if you assign 01 as input, it will accept single value from the user side. So if you assign AH as 02 means it will accept single character from the user side. So if you assign AH as 09 means it will accept string from the user side. For example, if you need two 8-bit data from user side means simply you will define AH01 as input. If AH01 has instructions in INT 21. So if you need characters from the user side means single character means you just define AH comma 02. This will accept the characters from the user side. Similarly, if you mention AH09 means this will accept string from users. I mentioned some example. So if you need data from user, so user typing some number in the keyboard. So if you want this number exactly to the program, so you need to type move. Accepting the data from user is very difficult in 8086. So if you type some numbers in the keyboard, so this will not give the exact number. For example, if you type 25 in the keyboard means this will not give the exact number 25 as input to the program. This will give the equivalent ASCII code value for 25. So if you want to convert the ASCII value again to the original number, we will need to use some set of codes. I will explain how to convert the ASCII code to the original number to do 8-bit addition. So first, if you need the input data from users, you will need to assign first. You will need to assign move AH comma 01 INT 21H. So if you define these two codes in the 8086 program, this code will help you to get data from the user side. This will help you. This will help you to get 8-bit data from user side. So if you type if you type 8-bit data on the keyboard, this command will help you to get 8-bit data in the screen. I will explain how to get inputs. Similarly, if you need characters, for example, if you need characters as input from the users, for example, if you need A as a character, if you need one character from user means you will need to use this set of commands. Move AH comma 02H INT 21H. So this command, DOS command, will help you to get single character input from the users. For example, if you need if you need string as a input from the users, if you need string as a input to the input from the users. Input means we just applying some value. For example, if you need string as input from the users, you will need to type move ah comma 09h int 21. This command will help you to get string input from users. String, I hope you know what is string. String is a group of characters. It contains different alphabets. So if you want a string input from users, you will need to type these two different set of lines in the 8086 programming. These are all the commands used by 8086 programmer to get data, character, as well as string from users. If you want data input from users in 8086 programming, you will need to type this set of codes. If you assign AH with value 01, INT 21H, this instruction will help you to get 8-bit data as input from the users. Similarly, so if you want character as input to the program, for a program means it having some, if you do some arithmetic operation, add, subtraction, multiply, divide. For that operation, it needs some characters. If you need some character as input to the program, you will need to type move ah comma 02. If you assign ah with value 02, this will help you to get single bit character as input to the program. INT 21H. This instruction will help you to get single bit characters from the users. Similarly, if you need string as input from the users, means you will need to type move ah comma 09h INT 21. So if you define these two set of instructions in programming, this will help you to get string input from the users. So next, this is the table. This will clearly explain how to give the instructions, how to accept data, how to accept strings from users, how to accept characters from the users. First, how to input a character from the string. For example, input means we just applying the input from the keyboard. So if you want to accept data from keyboard to the program, the input may be a data or input may be a character. So if you need to accept the data and character from the user side, you will need to use this set of commands in 8086 programming to get data from users. The code here is move ah comma 01h int 21. So this will take the user input character from the screen. This will help you to get user input data. The data will be entered by user side. User in the sense me as well as you. So you will enter some data. The data will be the data will go to program and it will do some operations. This will return a ASCII value of characters in AL register. So I will tell what it is. For example, in normally, if you enter any, if user enters any number in the keyboard, this will not give the exact. For example, if you enter 25 as input in the, if program asks the users to enter some value in the window, if you enter 25 from the keyboard, this will not accept 25 as input to the program. This will convert the input data. For example, I enter 25, this will convert the number data into a ASCII equivalent value. And then we will need to convert the ASCII equivalent number into a original number. There is some procedure is available to convert the number from ASCII value to original number. For example, if you want to add two 8-bit number means, if you enter any data in the keyboard means 25 as input from the keyboard means, this will not give 25 as input to the program. This will give only the ASCII equivalent for 25. So in order to convert the ASCII equivalent number again back to the original number, we will need to follow some set of steps to convert the number from ASCII to a normal number. So now I will explain how to convert numbers. For example, you are planning to do adding two 8-bit numbers. What is the command we will need to use in program to accept the data input from user means? First, we will need to use move al comma 01 int 21H. This is one type of DOS interrupt command in 8086. This mainly used by programmers to get data or characters from the users. This data is used for by the type of instructions are used by programmer to get 8-bit data or characters from users side. So after getting data, we will going to perform some operations. But normally in practical, so if you enter some data, for example, a equal to 25 and b equal to 30h. Now we will going to perform some add operations. So if you enter 25 in the keyboard, this will not give the 25 uh, directly as input to the programmer. This will convert the ASCII equivalent of 25 to the processor. So this will not, if you enter 25 in the keyboard, this will not give the 25 as input to the program. This will convert the assembler, convert the number 25 into ASCII equivalent value for 25. Similar, what is the ASCII equivalent for 2 here? What is the ASCII equivalent for 2 here? See here table. What is the value for ASCII equivalent for 2 here? This will give the value as 32. This will assign the value for ASCII equivalent for 2 as 32. So if you enter 25 in keyboard, this will not give the 25 as number directly to the program. This will convert the number into ASCII equivalent. ASCII equivalent. So, but it is very difficult to do ASCII number programming. So we will need to convert the ASCII equivalent number again back to the original number. Original number is the data what we entered in keyboard is 25 here. The same number we will need. Um, we will need at the output. We will need during programming. So now to convert the ASCII equivalent number for 25 again back to the original number, we will need to do some operations. Some operations. The thing you will need to follow here is first see. For example, if I enter number a equal to 25, so if user enters 25, the keyboard gives the ASCII equivalent for 25. So what is the ASCII equivalent for 2 here? For the table here, 2 here is 32H. And similarly for 5, the ASCII equivalent is 35H. So this will give the ASCII equivalent value for 25 as 3235 as input to the program. But program will not accept ASCII equivalent. You must need to convert the ASCII number again back to the original number. So now to convert this number again back to the original number 25, we will need to do some computations. First, what we will do here is first take the higher byte. First take the higher byte 32 and subtract this number with minus 30. So if you subtract 32 minus 30, you will get the answer as 2. Then rotate the number by 4 times. Then rotate the number by 4 times. Write the binary equivalent for. So if you subtract the higher byte with minus 30, you will get output as 2. Then next step is you will need to rotate the number by 4 times. So first I will explain how to do rotation. So what is the binary equivalent for 0 to 0 0 0 0? Binary equivalent for 2 here is 0, 0, 1, 0. So do rotation. So if you rotate this 8-bit number by 4 times, so you will get 20 as a output. See the this number goes here, this number goes here. If you rotate the number, any number by 4 different times, either towards left or either towards right, the number will be shuffled. See here, I write the binary equivalent for 0 to as 0, 0, 0, 0, 0, 0, 1, 0. So after first rotation, the number will be 0, 0, 0, 0, 0, 1, 0, 0. This number goes to this position. See here, 0, 0, 0, 0, 0, 1, 0, the 0 goes here. Similarly, after second rotation, what is the value? 0, 0, 0, 0, 1, 0, 0, 0. This 0 goes to right side. The output is this value. Similarly, what is the third rotation? This number go to this position. 0, 0, 0, 1, 0, 0, 0, 0. Then after fourth rotation, what is the value? 0, 0, 1, 0, 0, 0, 0, 0. What is the hexadecimal equivalent for 0, 0, 0, 0? 0, 0, 0, 1, 0 means 20. This is the output. So if you rotate the number 0 to by 4 different shifts, either by left or either by right, you can do any shifting. You can do left shift or you can do right shift. If you shift the number by 4 different times, you will get 20 as the output. See here, here 0 to, now output is 2 0. This number goes to this position, this number goes to this position after 4 shift. So you will get the output as 20. The higher bit operation is finished. So the thing here is, if user enters 8-bit number in keyboard, this will give the ASCII equivalent for this number. So, but program will not accept the ASCII equivalent. So we will need to convert the ASCII number again back to the original number. Means we will need to do some computations in 8086 microprocessor to get the original number again back to the program. First, we will need to take the higher byte, subtract 30, you will get the answer as 2. But refer the higher byte of 8-bit number, it is 2. So we will need then after getting the number, rotate the number by 4 different times, either towards left or either towards right. Rotate either towards left or either towards right, you will get 20 as the output. Then second step is take the lower byte 35 and subtract this 35 with 30. 35 minus 30. You will get output as 5. So after subtracting 30, you will get answer as 5. Then add the output results of higher byte with the output results of lower byte. After adding, you will get the original number as 25. 25. This is the procedure how to convert the number entered in the keyboard again back to the original number. The thing here is, so if you enter the number, if your program asks user input from you, means you are just entering the input through keyboard, but keyboard will not give the exact number what we entered in the keypad. This will give only the hexadecimal equivalent for 25. The hexadecimal equivalent for 2 here is 32. Hexadecimal equivalent for 5 is 35. We will need to do some computations to convert the ASCII equivalent number again back to the original number to do some operations in 8086. First, we need to take higher byte, subtract 30. We will get output as 02. Then rotate by 4 different types, either towards left or right. You will get 20 as output. Similarly, take lower byte, subtract 30, you will get output as 35 minus 30 is 5 here. Then add the output results of higher byte with output results of lower byte, you will get the output as 25. The user enter in keyboard is 25. That way, after computation, you will get 25 as output. This input is taken as input to the program, 8086 program, to do some computation. Similarly, the you will need to do computation for 30 also for second input. So if you want to do 8 data means first you will need to do the computation for A, then you will need to computation for B. Now we will see how to convert the number 30 entered in keyboard uh, um, to the original one. So for example, if user enters 30 as input to the program means this will not give 30 as input to the program. This will give one with ASCII equivalent for 30. So you will need to do some computations and then you will get the original number equivalent. This is given as input to the program. So now we will see how to convert 30 into uh, ASCII to the original number to the program. Now we already see how to convert the number 25H H here. Now, next number is 30H. You will see how to convert. For example, if user enters 30 as input from the keyboard means, but keyboard will not give the 30 as input to program. This will give only the ASCII equivalent for 30. See the table here. What is ASCII equivalent for 3 here? 33H. So ASCII equivalent for 30 here is 3 here is first see what is the ASCII equivalent for 3? 33. Then ASCII equivalent for 0 here is 30H. 30H. First process is what? First you will need to subtract the number 30 30 with 30. You will get one result. What is the result? 03 as the result. Then what is the next step? First thing is you need to take higher byte, then lower byte. First subtract the higher byte with 30, you will get result as 03. Then rotate 4-bit either towards left or right. After rotation, you will get the number as 30. I already told if you rotate 8-bit number, any 8-bit number with 4-bit left or either by right side, you will get this number goes to this position, this number goes to this position. If you have any doubt, just try convert this number into binary equivalent and the left shift or right shift by 4 different times, you will get the shuffled number. You will get 30 as the output. Similarly, take lower byte and subtract with 30. So you will get 0 as result. Then add the output results of higher byte with lower byte, you will get the original number. What you will get 30 plus 0, you will get 30H. So this input is given to this after getting the output result. This will be considered as input to the 8086 processor. This will be considered as B. So the thing here is, if you enter any number in keyboard, the program will not accept the exact number what you enter in the keyboard. The keyboard will give only the ASCII equivalent for number. If you want to convert the ASCII equivalent again back to the original number as input to the program, you will need to do this type of steps. First, you will need to take higher byte. ASCII equivalent for 3 is 33, ASCII equivalent for 0 is 30. First, do computation for higher byte, subtract 30. After getting the result, rotate this number by 4-bit towards left or right. you will get the number as 30H. Similarly, take lower byte, subtract 30, you will get some result. So add the output results of higher byte with lower byte, you will get 30 as you will get the original number, what we entered in the keyboard. This is the way how to accept the user input from keyboard. First, I already told how to convert 25 number to ASCII and ASCII to the original number. Now I explain how to convert 30 to ASCII and ASCII to the original number. So this command move AH comma 01 INT 21. This command you will need to add before before accepting any input from users. If you fail to mention this instruction means keyboard will not accept any input from, so the processor will not accept any input from keyboard. So before accepting any numbers, if you ask any numbers from the users, you will need to add these two type of instructions while doing the programming. So I will tell how to convert the number after getting the number from user side. You will need to do this type of computations. I will tell how to do the instructions and how to convert this one to a original one. So I will show the steps, processing steps, how to do that. This is the software we used for 8086 processor EMU8086. You need to download from internet and do some works. One thing I will need to explain. If you enter number from, if you enter any number from 0 to 9, so this will convert the number ASCII equivalent number into the original one, again back to the original number. For example, if you enter any number from A to F, um, uh, because hexadecimal we have numbers from 0 to 9 and A to F. If you, for example, if you enter any number from A to F, we have some set of process we have. So if you enter any numbers from 0 to 9, it's okay. If you enter any number from A to F, see here, if you enter any 8-bit input uh, using some alphabets, A, B, C, D, E, F, you will need to subtract with 30H, then you will need to subtract 7H. Now I will tell how to convert this one to original number. For example, if user enters 0 as input, for 8-bit data input to the, say example, for example, if you want to do 8-bit addition, you need two input variables A and B. If user enters first input as 0A, similarly if second input as 0B. If you enter 0A as input from keyboard, but keyboard will not give the 0 as input. This will give the ASCII equivalent for 0A. You will need to convert the ASCII equivalent for 0A again back to the original number. We will see how to convert this one. So if you enter 0A means this contains some alphabets. If number contains alphabets means you will need to use this process. Subtract 30H, then subtract 07H. See here, if user enters 0A as input, we will need to convert the number into ASCII equivalent. What is the ASCII equivalent for A? What is the ASCII equivalent for A? 41H. So ASCII equivalent for A here is 41H. Then next procedure is you will need to subtract with 30, minus of 30. Answer here is 11H. Then next step is then subtract 7 one more time. What you will get? 7 hexadecimal minus 7 hexadecimal. So if you subtract level minus 7H means, just refer the table. This is the um, hexadecimal flow. After 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0A, 0B, 0C, 0D, 0E, 0F, 10 level. Now the number here is level here. If you subtract level with minus 7 means, what is the output? So after before level, what will be available? 10. Then 10 to F, it goes to 0E, 0D, 0E, 0A, 0B, 0E. See here, if you subtract level minus 7 means, so this will give output as A. This will subtract one by one. Level minus 1, 10, 10 minus 1, 0F, 0F minus 1, 0E, 0E minus 1, 0D, 0D minus 1, 0C, 0C minus 1, 0B, then 0B minus 1, 0A. This will give the output results as A. But your aim is what? So if you enter A as input in keyboard, the same input you will need to apply to the program. So if you first convert ASCII equivalent for A into ASCII equivalent for A. The ASCII equivalent is 41H. Subtract 30, you will get 7. You will get 11 as output. Then subtract 07, you will get number as 0A. See the input, what you enter in keyboard is 0A. So after computation, the output you get is 0A. This is the way how to convert the ASCII equivalent to the original number. So if you enter any number from 0 to 9, we will need to follow this step of conversion. If you enter any number from A to F, you will need to follow this step. Subtract 30H, then subtract 07H. This is the way how to convert the user input from keyboard again back to the original number in program. So the main problem here is accepting the user input from keyboard is very difficult. So if you enter any number in keyboard, the keyboard will give only the ASCII equivalent. It will not give the original number as it is to the program. So, but program will not understand the ASCII equivalent. You will need to convert the ASCII equivalent again back to the original number. The procedure I explained already how to convert the ASCII equivalent number again back to the original number. This thing you will need to follow. So if you have numbers from 0 to 9, you will need to follow these steps. If you enter any number from A to F, you will need to follow these steps. First, you need to convert the alphabet equivalent, ASCII equivalent for A, and then subtract 30, then subtract 07, you will get the results. There is no need to do some left shift, right shift operation. That thing will be done only for numbers from 0 to 9. This is the command we will need to use in program to accept to get input from users. So for example, enter the first number means if user enter some number means this number. If you want the if you need this input to the program means you will need this command in 8386 program to accept user inputs. Similarly, if you need to accept string from the users, string means group of characters. So if you want to accept the input as string to the program, you will need to write this set of codes. Move AH, 0AH, LEA, DX, string, INT 21H. Here in this instruction, LEA stands for load effective address, also called offset address. This will assign the offset address of string to the DX register. DX register. So if you want string input from users, you will need to write these 3 steps in 8086 program to accept strings from users. Load effective address means this will load the offset address of string to the DX register. See here. Okay, just listen carefully. If you need to if you need string as input from string as if you need string as input from user, if you need string as input from users, input from user. For example, string here is, for example, SRM University. This one is string. If you need to enter these things, if you need to accept these things from the keyboard, means you will need to write this type of instructions while doing programming. These three instructions are very important while uh, while asking string input from users. Move ah comma. What is the command you will need to use to accept string from users? Move ah comma 0ah lea dx comma string int 21h. Move ah comma 0ah then lea dx comma string then int 21h. So LAA stands for low effective address or offset address. This will load the offset address of string to the register DX. For example, I gave the string with the size of 9, duplicate with some garbage value. Garbage value means question mark. It may be any characters. For example, this is the name for my string. This is the function name for my string. This is the number of characters in the strings. Duplicate colon. What it will do is, after writing these instructions in 8086 programmer, for example, string here is SRMUIIP. So DX is a register which pointing the offset address of each characters in the string. So LEA DX comma strings means DX will hold the offset address of all the characters in the string. So these three different steps are useful while accepting the string input from the user. If you want to accept string input from user, means you must need to use these three different lines in programming. So while discussing the programming, I will explain how to write this, how to where and how to write this set of instructions in program. So if you want to accept string input from users, what you will need to do? You will need to write first move ah comma 0a. This 0a will inform which function has to do by using INT 21. If you mention 0a means this will accept the string input from users. Similarly, in previously what we assigned the value for AH here, if you assign 1 as value to AH means this will accept 8-bit data or character from users. If you mention 0 as A as input to AH means this will accept this command. These numbers will determine which function has to do by the INT 21 interrupt. If you mention 01 means INT 21H will accept 8-bit data or characters from users. If you mention the value for 0 as A means INT 21 will accept string input from user side. So based upon the value, the INT will perform different function. If you mention 01 means this will accept data or the characters from users. If you mention INT 21 with 0A means this will accept string input from users. Okay. So how to display characters on the screen? So in programming, After doing the computation, you will need to show the outputs in the output window. So in order to display characters on the screen, you will need to you will need to mention these set of commands in programming while viewing the outputs. So move AH comma 0 to H, move DL comma character INT 21. If you assign the INT 21 as 0 to EMU, this set of instruction will help you to display a characters on the output screen. So if you want to display a strings on the screen, similarly, if you want to display a string on the output window, you will need to use this set of instruction. Move AH, 09H, LEA, DX, string, INT 21. If you assign 09 as input to INT 21, this set of instruction will help you to display the strings on the output screen. Similarly, if you want to terminate the program, terminate means after doing all the computation, if you want to do stop the operation or terminate the program, you will need to mention this set of codes. So before finishing the program, before exiting the program, you will need to write these three set of instructions. Move AH, 4CH, move AL, 00H, INT 21. If you assign INT 21 with 4CH and 00H to the register AH, this three set of instruction code will help you to terminate the program in 8086. So I will recall the concepts what we discussed today. INT 21 is a set of DOS interrupt, which is mainly used by system programmers to accept data from users, to accept string from users, and to display characters on the screen, output screen, and to display strings on the output screen. And if you want to terminate the program, we use some set of codes. So for example, if you want to accept input data, it may be 8-bit data, or it may be 16-bit data, or it may be character. If you want to accept user inputs, that means input data or characters from user, you will need to use these two line set of instructions. So if you want to accept strings from user means, you will need to use this set of codes or instruction. If you want to display a characters or 8-bit data or 16-bit data on the screen means, you will need to use this set of 3 lines. Similarly, if you want to display a strings on the output screen means, you will need to assign this, you will need to write this set of codes. Similarly, to terminate the program, to complete the program, you will need to write this set of codes to end the program. Clear? Just go through all these instructions, how to get data, how to get strings, how to display characters, how to display numbers, how to display strings, how to terminate the program. These steps are constant. These are the predefined default instructions used by system programmers to get data, to get strings, to display characters, to display strings, and for terminating the program. I told how to convert the number to ASCII and ASCII to the original number. This is the flow you will need to use. For if you enter any number from 0 to 9, you will need to follow this set of steps. If you enter any number from A to F, you will need to do this set of concepts to convert the original number entered in keyboard again back to the original number. This is the way how to do that. Just refer the slide, you will get some idea how to do all these things. This is all about INT 21. Next class we will discuss about programming, how to write program in EMU8086. The software we used here is EMU8086 programmer. This software is open source. From next class we will discuss about how to do programming, how to assign inputs, how to get outputs, all those things. So thank you everyone. I will discuss on next class. Thank you very much.